All right, today we're going to look at another inquiry lab. This will be on triangles. I'm sure most of us have some sort of background with triangles. We know that they're three-sided polygons. We know that they have a variety of lengths of sides and angle measures based on the different types of triangles that there are. We're going to focus our attention on some abstract concepts of triangles that you may not be aware of. So first of all, the question we're looking at, what is the relationship among the measures of the angles of a triangle? So in other words, tri means three, so there's three angles. What is the relationship amongst the measures of those three angles? Lamont has a metal bracket that is in the shape of an angle that attaches a bag to the frame of a bike. The angle of the bracket measures 35 degrees. Lamont wonders if it will fit into the frame of the bike by the handlebars. So in other words, if you're looking at this bicycle right here, the idea is that the frame of the bike kind of makes this triangle shape. Hopefully you can see it. Goes right there. That's a really thick red line. See, there's no way you can miss that now. Huh? There's the triangle right there, and they're giving us an 87-degree measure over here and a 55. No, 35? Yeah, it is 55 right here. So, and he's asking us if the bracket measures 35 degrees, is it going to fit in there? So there are ways to solve problems like that, and that's exactly what we're going to be doing, or taking a look at anyways, with this investigation. So, moving on. Triangle means three angles. Obviously, we just talked about that. You will explore how the three angles of a triangle are related. So here's what you're going to do. You're going to, with your piece of paper that you have, there is a triangle on it already, you are going to tear off the corners after labeling the corners 1, 2, 3. So take your triangle, write a 1 in the corner, a 2 in one of the corners, a 3 in one of the corners, and then don't be a clown about it, but tear the corners off. It doesn't have to be perfect. It doesn't have to be, it can be jagged or whatever. Just try not to make a big mess. And when you have your three corners, here's what you're going to do. You're going to rearrange the torn pieces so that the corners all meet at one point. So you're going to try your best. It's probably easier if I draw it on here. So like once you have your pieces, okay, you're going to take the corner of that piece, the corner of this piece, and the corner of this piece, and try to put them all together. All right, put them all together. What does each torn corner represent? Okay, well, think of it this way. You tore a corner off a piece, maybe you can answer this question by yourself. Yeah, the other day when we were talking about parallel lines and angles, we saw this symbol that goes like this. That's an angle measure symbol. So I'm going to do a 2 over here, and I'm going to do a 1 with a hash mark over here, indicating that right now, until I measure them, they're three different angles. I don't know. They might be, based on this diagram, it looks like they might be equiangular. In other words, they're all the same degree measure, but for the time being, I don't know what the measurements are, so I'm going to assume that they're all different. So now that you've put those together, label the torn pieces 1, 2, 3. They're already down there. What does each torn corner represent? Well, presumably you've got like a 1, and I'm just kind of looking at the pieces in the top and trying to match them up. A 3 and a 2. So what does each torn corner represent? Each torn corner represents one of the angles of the triangle. Okay? The point where these corners meet, let me move this thing out of the way, the point where these corners meet is the vertex of another angle. Classify this angle as acute, right, obtuse, or straight, and explain. Okay, so here's what they're trying to show you. Let me erase what we have so far over here and kind of come back to this concept. So hopefully you have yours just kind of sitting out in front of you. Maybe it's easier to look on this one, I'm not really sure. The idea was to kind of give you a hands-on experience here while you're doing it. So here's essentially what the idea is. If you consider that you've got the bottom of this piece that make the corners right there. You get the corner of this piece and the corner of this piece all come together to make what? That looks like a straight line to me, or at least not a line but a segment. You get the idea. So the other day we learned that this straight line is, if I was going to measure it how many degrees? 180. So again, if I'm considering that like this is the vertex and I'm measuring that angle, the whole angle should be 180 degrees. Correct? Correct. So the question then is 180 degree angle acute, right, obtuse, or straight? Well, acute means less than 90. Right means exactly 90. Obtuse means greater than 90. Straight means, that's pretty straight, isn't it? Straight angle is a 100-degree angle. So it is a straight angle, and then I'm going to go ahead and explain. It does say explain why. So it is a straight angle because, why? Because all the way here, these three angles combined, it measures 180 degrees. Okay? Not only is it because it's a straight line, obviously, but also what's more important is the degree measure. So it is a straight angle because the measure of the angle is 180 degrees. Boom, done. If you have questions on that, go back and review. Otherwise, we're moving on to the next page. Work with a partner. Hey, you're in luck. I'm your partner again. Isn't that fantastic? So repeat steps 1, 2, 3 for each of the following triangles. Draw or tape your results in the space provided. I don't think you have to do that. Here's what you are going to do though. You're going to use your protractor again. Okay, you're going to use your protractor. And here's what I want you to do. It's going to be a little bit challenging, but what I want you to do is I want you to measure angle 1. I want you to measure angle 2, and I want you to measure angle 3. And what I want you to do then is we're going to draw these angles in a specific way at the bottom. So what I'm going to do is I'm going to tell you, obviously, that if you combine those three angles, the same thing is going to happen as on the previous page, which is that you are going to get a straight angle. Alright, so here's what's going to happen. In fact, I'm going to need to move that because, whoops, I don't have enough room. I want to move this guy. Okay, there we go. So here's what's going to happen. I'm going to measure angle 1 and I'm going to come up with a degree value for that. Let's do that first. So I measured it, and what I determined is that angle 1 is 65 degrees. Okay. If you need help seeing that, I can come by and help you. Stop and raise your hand now, and I can help you with it. But I determined that this guy is 65. All right. I also measured angle 2. You can kind of tell by looking at it, but it does help to measure it. Angle 2 is 90 degrees. All right. So here's what I can tell you, and sometimes this is a little bit more helpful. You don't have to put these in any particular order. It does not matter because if, again, it's sort of the commutative property when you're adding three things together, the order is not important. You can add the angles together in any order. So what I would probably do personally is I'm going to construct, I need to pick a point on this line that I have created, somewhere hopefully right in the middle, to be my vertex. And out of the middle of that, I'm going to draw my 90-degree angle because it's a little bit easier to do that first. And then, so here's angle 2 over there. It was 90 degrees, right? Just do your best. The next thing I'm going to do is construct my 65-degree angle. So, and you're going to want to, it's going to be kind of flipped around from what it is here. Again, if you need me to explain that, I can. But basically, do your best. You're not looking for perfection. So here's angle 1. And here's angle 3 down here. And what I can tell you is that obviously the three of those angles combined are going to add up to 180 degrees. Did you happen to measure angle 3 while you were at it? If you do that, I'm pretty sure you get somewhere in the neighborhood of 25 degrees, which is what it should be. You know, assuming that the other ones are 90 and 65, because then what happens is if I add those up, I should get 180, and I should be in good shape there. So that's what we're looking at in terms of breaking those angles up. Again, if it doesn't make sense, I can help you. All you have to do is pick one of these angles to start with and then construct the other angles going forward. It's easy when you have a 90 because you can kind of start with that one and then do the other two. Really is pretty simple. At any rate, we're going to do the same thing with number 2. So before I do anything else, I am going to go ahead and draw the bottom of my straight angle here in the space provided. And then I'm going to take my protractor and I'm going to measure angle 2. I'm going to measure angle 1. And I'm going to measure angle 3. Go ahead and do that. Okay, so after measuring angle 1, it appears, I'm going to do the same thing down here. I'm just going to make a dot somewhere in the middle. And I'm actually going to try to draw this angle 1 exactly the way that it looks on here, which, no, that's going to come off like this way. I measured this, and this is angle 1, to be somewhere in the neighborhood of 140 degrees. A lot like with the line activity. When you're measuring the angles, if you're within about 1 or 2 degrees, generally speaking, it's okay because a protractor is not particularly a precise method of measurement. All right, it's kind of like using a ruler and using your estimation skills. If you're close, then generally speaking, it's pretty good. So the only thing then I'm going to have to do to finish this off here is measure angle 2. And based on my measurement of angle 2, I'm looking at a measurement of about 12 degrees for angle 2. This guy is 12. So if you're following along, we would be adding those so far to get a total of 152, which then would make angle 3 hopefully be somewhere in the, I'm looking for it, yeah, it's like 28, which is pretty much what I'm looking for, because then if I add these up, I'm also going to get 180, 168, 180. So here's the thing about this now. So when you're constructing these angles, think about it. 28 is a little more than half of 12. I'm sorry, more than twice 12, right? 12 times 2 is 24. 28 is a little bit bigger than that. So with this remaining space, it's not going to be exactly the same size. You're going to want to try to make one of them about twice as big as the other one. So this is where it gets a little challenging. But again, we'll give you a break because we're not talking about perfection. Just kind of want to make a tiny little piece that comes out of there like that. And actually, I'm going to redo that because I don't really like the way that that turned out. So just take a look here. They actually, I mean, they look like they're almost the same size, even though this is like twice as big. So it's kind of strange, but we'll just have a little guy coming off of there like that. And we're going to call this angle 3 because it's the bigger one. And we're going to call this angle 2 because it is the smaller one. And again, if I add these three things together, it is going to add up to 180 degrees. So as we move on here in our analysis, what is the sum of the measures of the angles for each of your triangles? So again, sum means that we're adding them up. Measures, we took them all, so the sum of the measures is 180 degrees. Verify your conjecture below by measuring each angle using a protractor. Hey, we're a step ahead. We already did that. So we know that now here's where you really need to correspond the correct measurements. So exercise 1 is right here. Angle 1 is 65 degrees. So I'm going to rewrite this in the order. In fact, I'm going to use my typing skills to do that, just so that it looks a little bit better. So angle 1 was 65, angle 2 was 90, and angle 3 was 25. So it is important here that you put these in the correct order, is in terms of corresponding them to the angle numbers that they match. But wait, you just said that the order is not important. Well, it isn't in terms of addition. You're going to get the same answer, but I want angle 1 to correspond to 65 degrees. I want angle 2 to correspond to 90 degrees, and I want angle 3 to correspond to 25 degrees. So while the sum will be the same no matter what order the numbers are in, I do want them to be in the order relative to 1, 2, 3. So there's 1, 2, 3 right there. And of course, we know that based on our calculation, it equals 180 degrees. Okay, we're going to do the same thing for this. Angle 1 was 140, angle 2 is 12, and angle 3 was 28. So we're going to go ahead and put that in the same order. I'm just going to change these numbers around. So again, we said angle 1 was 140 degrees. Angle 2 is the smaller one, so it's the 12, and angle 3 is 28 degrees, and that also equals 180. So there's our proof of what we did up here, and those three angles being added together equals 180 degrees. That is a fact about triangles. So as you reflect, refer to the bicycle problem on the previous page. Will the bracket fit exactly into Lamont's bike? Explain. All right, let's go back. So let me get rid of this stuff so that you can see it a little bit better now that we know what the triangle looks like. So we're saying that in this triangle I've got an 87-degree angle and I've got a 55-degree angle. I'm wondering if this can be 35. So here's the thing. Based on what I just did, I should be able to add these two angles together and get and then add the third angle to be able to get 180. All right. We're going to kind of work backwards, so to speak. 87, 55. We're going to work backwards, so to speak, to get what we need to get. So here's the, I'm going to do the explanation kind of over here. So I know that, and I just forgot the numbers I was working with. Sorry folks, it's been a long day. 87, 55. Okay. So I'm going to change this first value to 87. I'm going to change this to 55. And then of course we have the value in question that I'm wondering, can it be 35 degrees? Because 35 degrees is going to fit. All right, so the concept here is you could technically replace this with a variable and change this into an algebraic equation. So why don't we do that? And what's going to happen is I'm just going to use the word x, not going to get, or the letter x rather, I'm not going to get fancy about it. So I'm going to change this to a variable. All right, this is combined like terms over here, so I've got 87 plus 55 is going to give us 142. And then of course you could flip around the order of the variable if you wanted to. X plus 142 equals 180. All right, you see what I did there? I just combined these two things and changed the order around because again, addition, order is not important. So then I would subtract 142 from both sides. 180 minus 140 is 40, minus 2 more would be 38. So x equals 38 degrees. Okay, so well, that means for that triangle we're talking about over here, this third angle is 38 degrees. 38 degrees, okay, because the three of them together would add up to 180. The question was, will the bracket fit exactly into Lamont's bike? Okay, well, he has a bracket that is 35 degrees, which is not exactly 38. Close, but not exactly. So the short answer is no, it's not going to fit. And the reason is because he needs a 38-degree angle bracket and he only has 35. So the short answer is no. And then our explanation is going to be based on the fact that the angle needed is 38 degrees, right? Not 35. So it will not fit exactly. Okay, get that so you can see it. And there's your explanation. So then to finally answer the question, what is the relationship among the measures of the angles of a triangle? Okay, how many angles are there? There are 3. And simply put, the sum of the 3 angles of a triangle is 180 degrees. That is a fact. That is a geometric proof that we just helped to show. And you're going to want to commit that to your memory bank, not only for this year, but for the duration of your educational journey. The 3 angles of a triangle, when you add them up, is 180 degrees. I forgot my degree measure, so I'm going to go ahead and put that in there. It's important. So there you have it. There is Inquiry Lab 5.01 which leads us into, actually I don't know what it is, 5.11, whatever. I have a headache. It's been a long day. So this is going to lead us into our study of triangles and angles and relationships with remote interior angles and exterior angles and things like that. So hopefully this was helpful to you, and thank you for your attention. Have a great day.